All right, guys, welcome back. Feels like it's been a while since we last met, but yeah, I'm glad to have you all here tonight. We are looking at another concept, of course, within the talk of calculus and differentiation and all that. So at this point, we should understand differentiation up to a point where we can, note the difference between the two. Well, not only two various notations, including differentiating when there are more than one letters in an expression. And that's what we would have discussed previously. We have explained this. We also did some really complex expressions where factorization was involved. And I did say it is important at this stage when it comes to this part of the syllabus that you will recall your basic methods of factorization: highest common factor, difference of two squares, trinomials, including advanced trinomials, the sum and the difference of cubes. These are some of the methods you would have learned in grade 10, and it really becomes important to recall when you are doing questions like this. I do hope that you have gone through the paper one booklet and really gave it your best to try and solve some of those, or yeah, answer some of those questions. You should be in a position to do that at this stage. Now, what we're going to do today is we're going to get now to the graphing part of calculus. And I want to start off with some routine work that is very important and crucial for us to understand before we actually get to talk about cubic graphs. But this is the foundation to it, okay? And you will see some questions around this very same concepts. So let's talk about tangents for a start. Now, fortunately, this is not a new word from your Euclidean geometry in grade 11. You learned about the tangent, you learned about the tan-chord theorem and all that. So that same definition of a tangent is still applicable here. What you would have learned and established then is that a tangent is basically a line, all right, that uh, touches a line that touches a graph at exactly 1 point. That's what you would have established so far. So what I'm going to do for you now is to actually now show you how tangents are involved in graphs, okay? So suppose I've got a graph going like that, and then I've got a tangent at some point here. So touching the graph at that point. And obviously, because it's a straight line and we know the formation of a straight line, then one thing very important, guys, okay? It's important to note that then the equation of this line will be the line y is equal to mx plus c. This is what we call the slope point form. No, not the slope point form, the slope intercept form. So in other words, you are given the gradient and the intercept. Obviously, C is your intercept then. But then there is the slope point form, which goes like this. I think it's a minus here. So this second one is what we call the slope point form. Now, what do these tell you? They each tell you the following: that if you are given a gradient and a point, then this is, sorry, a gradient and an intercept. This is easy, quick to use. But if you are given a gradient and a point, then you can use that, all right? And then you simplify. But I mean, even the top one can still work with a point as well. So, but it's important to note that both of these are actually talking to the straight line. And fortunately, you are given this in your information sheet. You don't need to memorize them. You need to recognize them and know when to use them. All right. That is very crucial. Then we've got And I keep showing these arrows to show you that this graph goes on and on. So let's call this one f. The tangent, we said it's y equals to mx plus c. Now, remember what we said about the gradient. When we started talking about this concept of calculus, we said the reason we represent well, maybe not the reason. We said the power of calculus, in particular this first derivative, the first derivative actually represents the gradient. And not just a gradient, but it actually represents the gradient at a point. This is very important to understand. It represents the gradient at a point. I need us to first understand this important concept. So in other words, I can conclude and say between these two functions, okay? In other words, between the green and the blue, I can conclude that when I find the first derivative of the green, that first derivative is actually equivalent to the gradient of the tangent. This is critical. This is one of the important facts that will actually develop your understanding of calculus. If you do not catch this, I don't know, but you're gonna be lost half the time. So please make sure you understand what I just said. The first derivative is equivalent to the gradient of a tangent, actually. The first derivative of a function is equivalent to the gradient of a tangent at the point on that particular function or graph. Now, let me just point out this point here. Man, maybe let me just make it a bit clear. So I want you to note something now. We're talking coordinates. So let's suppose this point is called x1. Let's call it x1. Then I need you to note that there is a point on the y coordinate, f of x1, or if you like, if we maybe call the straight line g of x, this point will also be the same as g of x1. What I'm trying to make you aware is the fact that the point here, let's call this point P. The point P is actually a common point between F and G. It is a point of intersection, if you like, but this is not an ordinary intersection. It is a special intersection, okay? And this is what we will refer to. We have actually a term for this point. We call it a point of tangency, because that's where the tangent and the cubic graph meet. And as I said, math is a language, so there's going to be different words. That is why I am using these different words to refer to the same thing so that you may understand, okay? You may understand when you read a question and they talk about a point of tangency, don't overthink. Just remember, they are simply referring to a point between a graph and a tangent, which means it literally means the tangent and that particular graph have the exact same coordinates at that point. They share the point. I needed to establish that. Okay. Now, what often happens is they will just give you an x coordinate of the point of tangency. Sometimes they give you the x and the y coordinate of the point of tangency. All right. Or sometimes they might play around and give you a y coordinate of the point of tangency and then expect you to find the x coordinate of the point of tangency. In fact, I should say between these two, the key point that you will always need is actually the x value. It's the x value of the point of tangency, which you will often need, because that x value All right. Well, obviously, as an independent value, helps you to generate the Y value. But as I said, there's always the reverse process in mathematics. So don't just get used to knowing or working with the X value. Also, try and think of a scenario where you might be given a Y value and you're supposed to find an X value. Of course, I will try in my examples to include the different possibilities. But as I said, you always got to think out of the box. Always got to think of different scenarios in mathematics. And that is the objective of mathematics. It develops your thinking, critical thinking skills, problem solving skills. It builds you. And that is why the problem solving jobs in this world today require mathematics and science in some instances. So it is really, we pride ourselves as maths teachers in the fact that there's no career that thrives without mathematics. It is the heart, it is at the core. Even the careers where they say mathematics is not needed, it is actually needed because they do use it in any case, or whatever they use are products of mathematics. So you got to appreciate this subject. All right. Now, let us just take one example, and I want to use this to illustrate this fact here. This is I'd regard this as a level 1, level 2 question, really, because there isn't a lot that you are doing here, but this is just for us to build on the foundation. All right. Okay. So let's look at this example. This is the first example for the day. Worked example number 1. So it says here, determine the gradient. I'm going to be a bit lazy here in my writing, but I will say what I mean here. So determine the gradient of the tangent to the graph of f of x is equal to x cubed minus 2x squared plus 3x, not 3x, rather 3, at x equals to 2. So you see again, they have just given you an x coordinate of the point of tangency. What they are literally saying here is, look, there is a graph, cubic graph like that. But on this cubic graph, there is an instance where there is a tangent in the form y is equal to mx plus c, and it meets this. Now they are saying we have given you an x value here on the Cartesian plane. It is 2. That is the situation that you are given. And I want you to think right there and then that in a case where you were asked to find the point of tangency, the coordinates, the full coordinates, then you can actually substitute this value 2 into f, and that will give you the y value here. So whatever f of 2 is, that is the y value. Then you can get the full coordinates. You might come across a situation where you actually have to find the y coordinate. So it is very key that you understand what is going on here. In as much as you know your procedures and all that, guys, it is crucial to always know why you do something in maths, or where these methods come from, because that is what will help you to be able to do problems which you may have not seen before. All right. Now, remember there's a fact I highlighted here, or rather I boxed in red. And this is the fact that we're going to use. Okay. So to find the gradient of this tangent, we're going to use the fact that the first derivative of this graph is equivalent to the value of the gradient of the tangent at this particular point, x equals to 2. All right. So in other words, I don't have to stress about finding the gradient. I don't have to stress about knowing 2 points on the line. And that is the power of calculus now. By just knowing 1 point or one x value of a tangent to a graph, and of course, knowing the equation of that graph, just like that, you can find the gradient of the tangent. So let's find the first derivative. So the first derivative we're gonna use that. We know how to derive by now. So the first derivative will be 3x squared minus 4x. That's it. Now, I must substitute what? 2. So f prime of 2 is equal to 3 into 2 squared. And please take note how I use brackets here. It is very important because when it's negative numbers, you don't use brackets. It's going to cost you. So there it is. And I would encourage you really, if you, I mean, try and know this stuff off by memory. But again, if it's really, you're not that confident, it's okay. You can just weigh this thing as it is in the calculator. But this is where now memory work pays off than calculator, because you might just lose a minute punching this whole thing into the calculator, but it's fine. So this is 3 times 4, which is a 12. 12 minus 8 sounds like a 4. So now I get that equal f prime of 2 is equals to 4. But what does that mean? It means that the gradient of the tangent is actually 4, a positive 4 for that matter. Now, we can actually extend the question. You may take this as the second example for the day, but we can actually make up a follow-up question and say, you know, that question in the exam, which will go like, hence, you know, which will say hence, or otherwise determine the equation of the tangent. Remember that question. So as a result of what you have done previously, find the equation of what? Of the tangent. And it's a really easy question. And I want you to see, let's see what we have. From what we know so far is that the tangent is simply a straight line. So in the place of m, I'm going to put 4, and I have that. So I'm already in a crisis because I don't know the y-intercept of the tangent. But remember, how do you find the equation of a straight line? Well, when you have the gradient, the second thing that you need is a point. And this is exactly where this discussion of knowing what is going on here comes into play. So to find the point, I already know the x coordinate of the point. I need the y coordinate of the point. So to find the y coordinate of the point, I must use the original equation or expression of this function, which is f of x. So we spoke about it, and I've already written it for you here to say it is f of 2. So what is f of 2? Well, if you substitute 2, you're going to cube this. So it's 2 cubed minus 2 times 2 squared plus a 3. And again, you're welcome to use your calculators here, but I see an 8 minus 8 situation plus 3. So this looks like I'm going to have a 3 here. And someone can VAR that for me so that we don't carry on this, right? So it's been recorded, all right? So yeah, I mean, 2 squared is a 4, 4 times 2 is 8. So I do see a 3 there, which means the point of tangency, if I'm going to write the coordinates here, the coordinates will be 2 and 3. Now watch. I can then do the following. Okay, remember your coordinates, if they're like this, it means this is x, that is y. So I can literally then substitute here. Y is a 3, and then x is a 2. So what is happening here? I have 3 is equal to 8 plus c. But for this to be possible, c must be a negative 5. Therefore, my equation is y is equal to 4x minus 5. Now, let's say you don't like this equation. You like, no, I want to use the slope and point form. You are more than welcome to do that. Just take note of how long it's going to take. So y1 is a 3, the gradient is a 4, x1 is a 2. So we have 4x, we have a negative 8 there, we have a y minus 3, and if I write this in standard form, surely it becomes a 4x minus 5. These are equivalently correct. You may use one of the two methods. And I want to show you the beauty of mathematics and why I love this, why I believe in this. What I'm going to do now, I'm actually going to sketch the graph so that you kind of get a sense, you get to see how it looks like. And having sketched it, I will also sketch the equation of the tangent so that we actually see whether the coordinates of the point of tangency do really make sense in a visual sense. You don't need to really do this, but you know what? For educational purposes, I've got to do this for you. So what is my function? My function is x cubed. You also get to see how a cubic function looks like. So x cubed minus 2x squared plus 3. That was our function. And then we got that equation of the tangent as y is equal to 4x, and I think we said minus 5. And there is the story. As you can see that, look at this. Let's just try and zoom in a little bit here and maybe do some adjustments on the read. And I want you to really see how awesome mathematics is. Look at that. Voila. There we got it. There's our point of tangency, point A. It does resemble what we have actually picked up. And I want to show you, I'm going to scroll up a little bit here so that you see for yourself that indeed the tangent actually does cross the y-axis at a -5. So it must make sense because math always makes sense. So this is the situation that you were actually interrogating, but you were doing that without what? Without any visual, without any picture. And that's the thing. That's the beauty of mathematics. When you know your concepts thoroughly, you don't always need to draw a picture. You can always use these theoretical concepts to actually bring to life whatever it is that you want to catch. So this here, I think I got it on the wrong page though. Let's put it on the next page. So this here is exactly what you have been working with. You're going to learn how to sketch this funny graph. It might look scary and all that, but don't stress. In our next lesson, we are dealing with it actually, how to sketch it and so forth, which is why you were learning long division or you were learning how to solve cubic equations. That's the reason, because you're going to have to know how to find this x-intercept here, and you will find it by doing that method that we did. I will teach long division though, so that you know both ways of factorizing a cubic expression. All right, that is that. So this one was a straightforward question, right? I give you an equation of a cubic function, and then I ask you to find the gradient of the tangent as well as the equation of the tangent. Very nice and easy, straightforward. But we can tweak things around. Or as I said, you must also think of the backward process. And this is where now we're going to talk about finding the point of contact. So our second example deals with finding the point of contact. The point of contact, or you may say the point of tangency. Right? Now, it's just a backward, as I said, it's simply a backward process of what we just did. So watch this. Here it is. We are given that f of x is equal to -2x squared plus x. All right? Given that this f of x equals to -2x squared plus x has a tangent, listen to this, has a tangent with a gradient which is equal to 9. Number one, determine the coordinates of the point of contact. Of the point of contact. Obviously, the point of contact between the tangent and the graph. And then number two, determine the equation of the tangent. This one you will do because it's quite simple. We just did it. So equation of the tangent. So I will do the first one because that's really when the things are relatively new, but then you will do the second one to show me that you are following with whatever we are discussing. All right. So now, one of the little things I will always want you to think about is what kind of a graph am I dealing with? As you can see, there's no cubed here or there's no x cubed term. So you need to think basic and say, oh, I'm dealing with a parabola. It's an x squared term. So you are literally dealing with this type of a situation. You are dealing with a parabola. And what kind of a parabola is this? Oh, well, it's one with a sad face. We don't need to worry about accuracy, but the point is the one with a sad face. In fact, if I were to be a little bit accurate and more accurate, I can tell you there is an x-intercept which is 0 here. So x into so it's if we were to be more accurate, it's a parabola that looks like that. Okay. Now the gradient of the tangent is 9. Now I want you to take note that the gradient is positive. It's a positive 9. And because it's a positive 9, you need to know that whenever a line, a straight line has a positive gradient, it means it is increasing. So the point of tangency arguably could be on this side of the graph, anywhere on this side of the graph. But and this is important because if you're going to think that the point of tangency is going to be like that, then you are getting it wrong. Or if your line looks like that, you are getting it wrong. Just after this, I'm going to talk to you guys about the slope man. It is very important to understand the properties of a straight line as we deal with calculus. You will see how easy life becomes when we understand the properties of the straight line, because it will help you to understand help us to understand what you call this, the derivative, actually where the graph is increasing, where the graph is decreasing, that kind of a thing. So please, please, please make sure you follow closely here. All right, now watch. Watch what's about to happen. I want the coordinates of the point of what? Of contact. We said this literally means you are doing what? The reverse process. But what do we know? We know, remember that red box, we know for a fact that if I find the first derivative of this graph, then it will be equal to the gradient of the tangent. That's what I know. Now, what is the first derivative? Well, if we find the first derivative, we are getting a negative 4x plus a 1. I hope you agree with me then. Now, what is the gradient of the tangent? Guess what? It is given. It's a 9. Just like that, our troubles and sorrows are away because we do note that x will be a negative 2, which means, is it a negative 2? Yeah, it looks like it. 9 minus 1 is an 8, right? Yes. And then we get a negative 2. All right. Then watch now what happens. I'm going to find the y coordinate because they said find the coordinates. Now, please, guys, remember, when I find the y coordinate, I've got to substitute into the original, okay? Plus or minus 2, I'll just say minus 2 then. Now, what does this give me? Positive 4 times that's a negative, this looks like a negative 10. And someone must verify it's a Sunday. My math might not be quite well, my mental math. So yeah, 4 times that's a negative 8 minus 2 is a negative 10. So it does appear negative 2 and 10, not 10, but negative 10. Those are our points of tangency. Actually, then this means, yeah, I think I swapped up the 2 and the negative 2 here in my mental math. This is actually how our parabola looks like, which means we are looking at a tangent somewhere here, not as I had originally thought. Okay, but the shape is quite correct. Now, we are done answering the question. I want you to find the equation of the tangent. Once you have found the equation of the tangent, which I'm also going to do here, of course, I will then sketch this so that you see how beautiful and awesome this math is. So guys, please, in just 3 minutes, please find the equation of the tangent. You know the gradient, you also know the point. It can't be that difficult. Go for it, please. And once you are done, someone can just type in the chats there, the equation of the tangent, or you can call it out. You just unmute and call it out for me. Go for it. I see we have a winner. So someone has given the equation 9x plus 8 is the correct answer. Well done, Taban. That's perfect. Beautiful, guys. I'm glad you are following and coming right with this awesome stuff. Now, what are we gonna do now? Okay, how about this? Let's do another fun example. This is quite a nice one actually, because it integrates your knowledge of analytical geometry as well. So it's checking whether you still understand, if you see where the integration of these concepts. Okay, so the question then says you've got the graph. Where is it? You've got again the graph of a function, f of x again, x cubed, we're using f of x a lot today, x cubed plus 3x squared minus 4x. Now listen to this. This graph has two tangents, that are parallel, and that's your keyword right there, parallel to the line. Now, the line is y minus 5x plus 7 is equal to 0. And obviously, the classical question is determine the equations of both tangents. And as I said, my handwriting may not go with what I say, but please do believe what I say. By the time we finish this topic, you would all be used to this writing, I promise you. So my apologies. Okay, let's look at the solution to this beautiful example. Awesome stuff. So I've got a cubic function, all right? It has two tangents. These tangents, keyword, they are parallel to this line. Now, one of the things that you need to remember from Euclidean geometry is that if I've got one line parallel to another line, the implication is that the gradient of this line is equal to the gradient of that line. Another word to note is the word perpendicular. If I have, just in case it comes or you come across it, if I know that some line y1 is perpendicular to some line y2, then I note that the product of the two gradients, if I multiply the gradient of line 1 by the gradient of line 2, I must get a -1. Now, there is another word that might pop in, and I think I must just throw in this word. Sometimes they might talk about a normal line. A normal. A normal is actually a line which is perpendicular. So please note that a normal is perpendicular to a tangent. So in case you come across that word, a normal is a line that is perpendicular to a tangent. Please beware of that, which means if they tell you that there is a line which is a normal to a tangent, then you must note that relationship in green, okay? I've not seen it in a while, but I've seen it sneaking it here and there. So just in case, it's important that you know what a normal is. Right. Now, how do we go about this, guys? Well, since these two tangents are parallel to that line, we just need to find the gradient of this line. Now, please listen carefully. If you are thinking the gradient of this line is a -5x, you are in trouble, because it is very important to note that the gradient of a straight line is only established when the straight line is in standard form. Y is equal to mx plus c. So that is not the case here. So I need to rewrite this in standard form and watch what happens. Once I rewrite it in standard form, the gradient is actually a positive 5 and the y-intercept is a negative 7, not a positive 7. So please, standard form is very important. Whether you are dealing with a linear or a quadratic, I advise you to always take note. Write stuff in standard form. It does save. Sometimes, guess what? You get a mark for doing such. Right. So now we actually know that for both tangents, so therefore for both tangents, the gradient is actually 5 because they are parallel to this line. So it means they have the same gradient as the line. So for both tangents, the gradient is equal to 5. These are the few marks that you can score by just writing down what you are thinking. Now, remember the red box? So it's time to bring that to class. So we will note then, therefore, it would mean that the derivative of what? The actual graph is equal to what? 5. That's what it means. Okay? Now, what is the derivative? Okay, remember we have to find the equations of these. Okay, so what is the derivative? You will note that the derivative is 3x squared plus 6x minus 4. So this is already equal to what? 5. Now, just like that, I note that I have a quadratic equation, and this makes sense because I'm expecting 2 points of tangency here, so I must have 2x values. All right? So let's write this. A quadratic equation, you always write that in standard form because you're going to factorize or you use your quadratic form. So it's like this. I'm going to reduce it by dividing by 3 because I noticed 3 goes into all these terms. So this will be a 2x. That will be a minus 3. So it's nice and easy to factorize this. X plus 3, x minus 1. Therefore, I have two options. X is a negative 3 or x is equal to a 1. And what this should tell you is the one tangent touches the graph when x is a negative 3, and the other tangent touches the graph when x is equal to 1. So you are basically doing what we did previously here, but twice. Okay? So remember, we cannot find the equation of the tangent unless we know two things: the gradient and the point or the coordinates, the full coordinates, x and y, full coordinates of the point of tangency. So we're going to do that just now. Okay, so maybe, nope, let's not do that. I'm not going to impose. I need you to find them. I think it will be better. This is a way of actually checking if you understood the previous question. You'll remember in the last lesson, I used to give you questions. But now that I have helped you, I have found the one x coordinate, the x coordinate of one point of contact and the other. Please, won't you go ahead and find the equations of the two tangents? I'll give you about 7 minutes to do that, which is more than enough. If you finish on time, type in both equations so that we continue. Okay, so we're going to start with x equals to 1. So when x equals to 1, what is the point of tangency? That is the question you should be asking. Well, it means I must substitute 1, right, in the original equation. So 1 cubed plus 3 times 1 minus 4 times 1. So this looks like I've got a 4 minus 4, which is a 0. So that means the point of tangency for this particular tangent will have the coordinates 1 and 0. And then when I find the equation, all right. So Kamvana, we are verifying Tabang's calculation. So Tabang Kamvana says she agrees with 5x minus 5. So let's see what happened. And we'll use both methods. So if you use the method y is equal to mx plus c to find the equation of the tangent, then we're going to do a substitution. The y value is a 0. The gradient, we already know it is a 5. The x value is a 1. And then we are looking for c. So surely c is a minus 5. So we get y is equal to 5x minus 5. If you are not convinced, we can use the method y minus y1 is equal to m into x minus x1. So this is y minus a 0 into a 5, and then x minus a 1. And surely, without really much debate here, we have 5x minus 5. And then the other one, guys, for x equals to for x is equal to minus 3, you should get the equation y is equal to 5x plus 27. That's what you should get. All right. Okay. Sorry, Taban. Okay, you made a mistake. Okay, it's fine. Well, VAR check has been completed in any case. All right, we move on to, I want to leave you guys with some difficult examples. And then I believe after doing these examples, we're going to be okay after this. All right. So it's good to make mistakes at this level of the game, by the way, instead of making it in an exam where it's going to be costly. So that's a good, honest mistake. I'm okay with that. All right. Let's just do a little bit of high order questions that involve some sort of a bit of more thinking than the ordinary. We have really done the ordinary now, and I would just like to challenge you a little bit more with stuff that is a little bit extraordinary. So let's take this one as an example. Look at this. Listen to the question now. The gradient of the tangent to the graph of f of x equals to, what's this, x cubed plus kx squared at x equals to 2 is a 4. Obviously, the question will read, determine the value of k. All right. So you see, we are becoming more and more abstract now. Still, the fact that this is a matter of discussing a point of contact between a tangent and a cube does not change. We're still working on that basis and on that fact. So it's just that because we do this, we have thrown a k now in the original equation of the graph, and students get thrown away by this. But again, guys, watch how easy it is to do this. All right, let's read. As I said, it is always important that you read, but as you read, you pay attention to the vocabulary, the terms, the words that are used, and you try and decode those words. The secret really to success in an math exam is understanding the meaning of the words that are used in a question, and obviously following the instructions. So we are given the gradient of the tangent, and that gradient of the tangent is actually 4. So if you just look at this complicated statement, they are saying that the gradient of the tangent is 4 when x is equal to 2. So what does this mean? It means then when I find the derivative of f and I substitute a 2, I can actually equate that to a 4. Now that's what this whole thing is saying. Now, what is the instruction? Determine the value of k. Now you understand why last week's lesson was important, where we learned how to find the derivative even when letters are included in an example. That's exactly the situation we are faced with right now. I have f of x is equal to x cubed plus kx squared. And I am finding a derivative here with respect to x, which means everything else which is not an x must be treated as a constant. So the derivative here becomes 3x squared plus 2kx, if you remember carefully, or we remember quite well what we did. That's what it becomes here, all right? 3x squared plus 2kx. This is very, very important to understand, right? We have to get this. Now, we now know that the derivative is equal to what? 4. That's one thing that we know, because this is what f prime is. Now, fortunately, we also know the x value, which makes this thing to be equal to 4. That x value is 2. So it means if I substitute 2 here, I can then have an equation with in terms of k. So let's just check quickly here. 2 squared is a 4 times 3, that's a 12. And then, so that means I have 4k is equal to 4 minus a 12, which is a negative 8. So that means k is equal to a negative 2. What does that tell us? It tells us that, well, we have answered the question, by the way. They didn't say now find the equation. So, but it tells us that our equation is x cubed minus 2x squared. That's what it means. All right. And I want us to verify this working here to be, and just for fun. So if I find the equation of the tangent is going to be 4x plus a c. So to find that c, I need the point of tangency. And I can do that by substituting a 2 into this equation now that I know what k is. Okay, so this is an 8. Oh my word, can you believe it? I see an 8 minus 8 here. So that means this is happening at 2 and 0. So if it is happening at 2 and 0, what is the value of c? It looks like c will be minus 8. Well, is that the case? Yeah, y is 0 and x is 2. So c is a negative 8. Now, this means we have 4x minus 8. So am I correct? Is this accurate? We got a C. When we sketch this 2, and that's what I'm going to do now, I'm going to sketch x cubed minus 2x squared as well as a 4x minus 8. If this is indeed true, we expect them to meet at 2 and 0, which looks like the x-axis. So let's just change this, modify it to an x cubed. Gonna change this one to an x cubed minus 2x squared, actually. So that's what it is. And my tangent, if I remember, did we say 4x minus 8? Yeah. So 4x, we just need a minus 8. We already have a 4x. Okay. And there is the math making sense again. Just there at point A, we do have a point of tangency. And that's how we're going to know that we did not just cook, we also ate. Right, great stuff. Lovely. Now, there's another nice complicated example, which I would like to leave you with. And I would like you, well, let's say maybe we'll do this together. I don't know, but it's the same thing, guys. It's the same thing. Yeah, I think you can try this. I think this might require a simultaneous equation type of a situation, but let's see. Try this. A line with gradient m is equal to -3 is a tangent to the graph of y is equal to ax squared plus bx plus 3 at the point 2 and 5. You see, here they've given us the point of tangency, and obviously the question will then be determine values of A and B. That will be the question. I want you to also note, I think I'll do this one. I'll leave you with another one because there's a notation issue here. I also need you to note that instead of being given f of x, I'm being given y. Now, in this case, it is then important to note that what you usually write as f prime of x is actually what you're going to write as dy dx. Because now I know the expression is y, it's not f of x. So if you're going to use f of f prime x instead of dy dx, I want you to note that you're going to be penalized for notation here. Okay, so it's important to note that in this case, we're going to say dy dx is actually the gradient, which is a -3. Now, what is dy dx? Again, you see why it was important to note how to differentiate with respect to other letters. So now dy dx, if you will, it is 2ax plus ab. That's all. That's what it is. The constant is a 3, and we established that the derivative of a constant is 0. So this is what dy dx is. And what is this dy dx? This dy dx is the gradient. So we already know it is equal to a -3. So this is going to be my first equation. My second equation will come from the fact that I have a point of tangency. I have the full coordinates of the point of tangency. So when I substitute into the original now, y is a 5 and x is a 2. And I want you to see why I said simultaneous, because now this gives me my second equation. So this is a 4a plus a 2b. Watch carefully now. This will be equal to a 2. And I hope you see what happened there because the 3 just went to the other side. Okay. So this is quite key to understand, all right? So now I've got two equations, two unknowns. That is good news because it means I can actually find these two unknowns because I have two equations, right? Whether you want to use elimination or substitution, it is up to you, but I think we are all used to substitution. So using equation 1, from equation 1, I will just make B the subject of the formula there. Then I will get -3 minus 2ax. And I'll call this equation 1.1 because I derived it from the first equation. Then we know the next step is to substitute this equation in the one equation that I have not used, and obviously that is equation 2. And I'll continue right here. When I do that, I will have 2 is equal to 4a plus 2 times what? So in the place of the b, I have -3 minus 2ax. So this becomes 4a, guys. Basic board must please sort out the brackets before you do anything else. So that's -6 minus 4a. Do you see what I did here now? I think I forgot to substitute the value of x. So that's fine. We will substitute it. Is that what someone is asking here in the audience? Oh, Tabang, sorry. The next one, I'm not helping Tabang. Tabang is excited today. He's fired up to do some math. That's good, Tabang. That's good. Well done. Well done. All right. So guys, I should have done this earlier, but it's not a train smash to do it now, okay? Remember, this gradient of -3 happens when x is actually a 2. So I just forgot to substitute x equals to 2. I'm noticing that now that I have to solve for a. So 4a minus, so please take note that I'm substituting x equals to 2 there because that is the point of tangency. We all know this by now. So I'm going to have minus 8a. 4 minus 8 is a minus 4. So now this means a is a negative 2. And if I know that a is a negative 2, then b will be minus 3 into 2 times negative 2. But we already know that x is a 2 then. I should have actually substituted that to avoid this complicated thing. In my mind, I had substituted it. So minus 3 plus 8. This looks like a 5. So there you have your values of a and b, both, well, one is negative 2, the other is a 5. So I just thought I should do the simultaneous. Don't worry, Tabang. The take home is a very exciting problem. It's a very exciting one. So it's a test. Consider this as a test for the day. If you really understood today's task or today's lesson, then you should be able to do this. And because of that, I will write this one. I will try and write it in a readable manner. So the equation of the tangent to the parabola defined by y is equal to px squared plus qx at x equals to 3 is y is equal to, watch this, 15x minus 18. You know the question already. Determine the values of p and q. Now, this is the part where once you are done, you're more than welcome to send me the solution directly there or via WhatsApp. Otherwise, I will just stay in for the next 5 minutes to see who's got the values of P and Q here. But then having that done, that will then be the conclusion of the lesson. All right, guys, please try this. Do it now while you are still heated up, while you still remember these things. Otherwise, this will be it for today. Thanks for coming in, even when others are having a long weekend. You will see the rewards of the sacrifices soon, guys. Well done for tuning in. Cheers.